Let's solve this together. We subtract 0, 0, 1, 1 from 10, 10. Start from the rightmost bit. When we see 0 minus 1, we borrow from the next bit. After borrowing, continue subtracting each bit. The final answer is 0, 1, 1, 1. So, 10, 10 minus 0, 0, 1, 1 equals 0, 1, 1, 1, which is 7 in decimal. Why do computers use binary numbers? Because electronic circuits have only two stable states. They are on and off. These two states are represented as 1 and 0. That is why computers use binary numbers to process and store information. So the correct answer is B. Let's solve this subtraction. We need to calculate 52 minus 18. Subtract the ones first, then subtract the tens. The answer is 34. You can check it by adding 18 and 34. They equal 52. So the correct answer is C, 34. Let's compare this with decimal subtraction. In binary subtraction, when we subtract 0 minus 1, we must borrow from the next higher bit. This works exactly like decimal subtraction with borrowing. The borrowing process is the same. Only the number system is different. So the correct answer is C. Decimal subtraction with borrowing. Here's an easy one. What is 0 minus 0 in binary? When we subtract 0 from 0, nothing changes. The answer is simply 0. No borrowing is needed. So the correct answer is A.0. Let's solve this simple binary subtraction. What is 1 minus 0? When we subtract 0 from 1, the value stays the same. So the result is 1. No borrowing is needed. Therefore, the correct answer is B. 1. Let's solve this binary subtraction. What is 1 minus 1? When we subtract 1 from 1, nothing remains. The result is 0. No borrowing is required, so the correct answer is C.0. Here's an important rule in binary subtraction. Which subtraction always requires borrowing? The answer is 0 minus 1. You cannot subtract 1 from 0 directly, so you must borrow from the next higher bit. After borrowing, the subtraction becomes possible. Therefore, the correct answer is D.0 minus 1. Let's solve this binary subtraction. We need to calculate 102 minus 12. Since 0 minus 1 is not possible, we borrow from the next higher bit. After borrowing, continue the subtraction. The result is 0112. We remove the leading 0, so the final answer is 112. Therefore, the correct answer is D.112. Let's solve this binary subtraction. We subtract 01112 from 101112. Work from the rightmost bit, one bit at a time. Borrow only when it is needed. After completing the subtraction, the result is 1002. Therefore, the correct answer is D, 1002. Let's solve this binary subtraction. We subtract 01112 from 101112. Work from the rightmost bit, one bit at a time. Borrow only when it is needed. After completing the subtraction, the result is 1002. Therefore, the correct answer is D, 1002. Voiceover script, slow and short. Let's solve this binary subtraction. We subtract 01112 from 101112. Start from the rightmost bit and work left. Borrow only when it is needed. After completing each step, the result is 1002. Therefore, the correct answer is D, 1002. Let's solve this binary addition. We add 10,112 and 11,011. Start from the rightmost bit, add each column, and carry 1 whenever the total is 2 or more. Continue until all the bits are added. The final answer is 101,002. Therefore, the correct answer is D, 101,002. Let's solve this binary addition. We add 10,112 and 11,011. Start from the rightmost bit, add each column, and carry 1 whenever the total is 2 or more. Continue until all the bits are added. The final answer is 101,002. Therefore, the correct answer is D, 101,002. Let's solve this binary addition. We add 10,112 and 11,012. Start from the rightmost bit. Whenever the total is 2 or more, carry 1 to the next column. Continue until every bit has been added. The final answer is 100,011. Therefore, the correct answer is D, 100,011. Let's solve this binary addition. We add 1011 and 101. Start from the rightmost bit. Whenever the total is 2 or more, carry 1 to the next column. Continue until all the bits have been added. The final answer is 10,002. Therefore, the correct answer is D, 10,002.